All right, good day. We are still on binomial theorem. Our last lesson, we expanded the expression x plus y raised to power 7. Okay, now we want to expand x plus 2y all to the power 5, and then use that expansion to evaluate 1.02 all to the power 5. Now, we're going to see how this is going to be using calculator to punch that 1.02 raised to the power 5 will still give us the same thing we're going to get if we use the binomial expression for this to evaluate that. Now, it's quite very simple. So what we're going to do, we remember that from our last topic, I said that when we are evaluating x plus y, expanding x plus y raised to the power n, with the binomial expansion, when n is a positive integer, we use the formula. We use the formula nc0 xn y0 nc1 xn minus 1 y1 plus nc2 xn minus 2 y2 plus plus ncn x raised to power 0 y raised to power n. This is the formula we use in the binomial expansion when n is a positive integer. And then we replace the binomial coefficients. Students normally like using the Pascal triangle. So we can replace the binomial coefficients by the Pascal triangle, the Pascal formula for x plus y, the Pascal formula for x plus y raised to power 7, which is 1, okay? Remember how we generated it? 1, 7, 21, 35, 35, 21, 7, and what? 1. Okay, this is how we generated it. But today, we are looking at x plus y raised to power 5. We're looking at x plus y raised to power 5. So we can generate it. We have 1. The next one is 1, 1. Okay, we have 1, 2, 1, 1, 3, 3, 1. Okay, this is for x plus y raised to power 3. We have 1, 4, 6, 4, and 1. And then we have for x raised to power y raised to power 5, we have 1, we have 5, 10, 10, 5, and 1. So this is what we are looking for. This is what we're going to use to replace the binomial coefficients. So now we want to expand x plus 2y raised to power 5 using n is 5, 5c0 x raised to power 5, then 2y raised to power what? 0, plus, because 2y here is replacing y, okay? 2y here is replacing y, so it's going to be 2y all to the power 0. The same thing you have here, 5c1, you have x raised to power 4, the power of x begins to reduce, then the power of 2y begins to increase. The next thing is 5c2, okay, power of x continues to reduce, the power of 2y continues to increase. The next one is 5c3, x raised to power 2, 2y raised to power 3, okay, plus we have 5c4, x raised to power 1, and then you have 2y raised to power 4, plus 5c5, x raised to power 0, then you have 2y raised to power 5. Now, this is just the expansion. We can break it down, okay? We can just break this down. We can break this down, and then we have This is going to give us, remember that 5c0 is 1. So we have 1, and then 2y raised to power 0 is 1. So what is left there is just x raised to power 5 plus 5c1 is 5, x raised to power 4. You have 2y raised to power 1. So 2 times 5 is 10. So here we have 10x raised to power 4. Okay, we have y there. Plus, okay, we have 5c2. 5c2 is 10. Then you have 2 raised to power 2 is 4. 4 times 10 is 40. You have x raised to power 3, y raised to power 2, plus 5c3 is also 10. Okay, 2 raised to power 3 is 8. 8 times 10 is 80. 80x raised to power 2, y raised to power 3, plus 5c4 is 5, and you have 5 times 16. 16 times 5 is 80. Okay, you have x, y raised to power 4, and finally, 2 raised to power 5 is 32. 32 times 1 is 32. So you're having 32. X raised to power 0 is 1. So what you have here left is y raised to power 5. So this is the binomial expansion of x plus 2y raised to the power what? 5. Now we go ahead to evaluate. We want to evaluate 1.02 raised to power 5. Now what we do is to put it in the form, separate the integer from the decimal fraction. This is 1 plus 0.02 raised to the power 5. Compare this with the expansion for this. Compare this. If you compare these two, you see that your x is equals to 1 and 2y is equals to 0.02, which means that y is equals to 0.02 divided by 2, which is 0.01. So my y is 0.01 and my x is 1. Therefore, we can have 1.02 raised to the power 5. Using the expansion, we can evaluate that. We have our x, which is 1. So we have 1 raised to the power 5 plus 10 bracket 1 raised to the power 4. Y is 0.01. I'm replacing x and y with these values here, plus 40, 1 raised to the power 3, 0.01 raised to the power 2, plus 80, 1 raised to the power 2, 0.01 raised to the power 3. This one, 80, 1 raised to the power 1, 0.01 raised to the power 4. Then finally we have 32, 0.01 raised to the power 5. Now we go ahead to evaluate using our calculator. Okay. Here we already have 1 raised to the power 5 is 1 plus. So let's evaluate that. Let's evaluate the second one. The second one is 10 times 0.01. 10 times 0.01 is 0.1. So this one is 0.1 plus, let's evaluate this one. Okay, 0.01 times 0.01 times 40 will give us 0.004 plus, let's evaluate this one. You have 0.01. Okay, 0.01 times 0.01 times 0.01 times 80 will give us 0.00008 plus that one. That one is 0.01 times 0.01 times 0.01 into 4 places times 80. Okay, will give us 0.0000008 plus, then the final one is 0.01 raised to the power of 5, okay, times 32 will give us 0.0000000, okay, 32, okay, this one is 4, this one is 6, okay, this one is 8. That's what it gives us. So we can now add up everything together to get the final results. We have 1 plus 0.1 plus 0.004 plus 0.00008 plus 0.0000008 plus 0.000. I have about about 8 zeros, okay, 32. So the final result becomes 1.10408032, okay? So this is what we are going to get from the binomial, after getting the binomial expansion for x plus 2y raised to the power 5, use the expansion to evaluate that. That's what you're going to get.